Here we're looking at sketching this function here. We can see that this is a quadratic, which is written in the completed the square form. So this makes another connection here with a quadratic, sketching connected and the relationship it has with completing the square. Well, the completing the square form is simply a form which actually shows us all the transformations that have been applied to the original y equals x squared. So suppose we had the original y equals x squared. How did we get from this to that form? Well, let's take a look at all the things that have been applied to it. So the original x squared, what would have happened to it? It's been multiplied by 3. Okay, so there's a multiplication there. So this is inside the bracket, so fx x, and the scale factor is 1/3. Then we've got this minus 4. What's that doing? Again, it's inside the bracket, so fx x and translation by vector 4, 0. Since it's in the x, we do the opposite. Then we've got this 2 outside the bracket, so this affects y. And it's a scale factor because it's timesing, scale factor of 2. And then we've got this plus 1, which is outside the bracket again, and that affects y and translation by vector 0, 1. So we have 4 transformations applied here. Now we've got 2 applied in the x direction, 2 applied in the y direction. Now the order in which we do these transformations is of importance. Now the order in which we do the x first of all, and then we look at the order in which we do the y. So with the x's, we always kind of doing the inverse. So normally we would follow Bidmus, but we would do the opposite with x. So instead of doing the timesing or dividing, we would do the adding or subtracting first. And adding or subtracting is related to translation. So we would, in the x direction, it's always the opposite of Bidmus. So we do the translation first. So that would be first, followed by the enlargement second in the x direction. In the y direction, which one do we do first? Well, we always apply, it follows the same rule as Bidmus. We do the applying the times or divide, which is the scale factor, enlargement first, followed by the translation, which is the add or subtract second. What about, do we do the x transformation first or the y transformations? That doesn't matter. You can do either x or y first. You will get the same graph. So x and y transformations are independent of each other. X and y transformations are independent of each other. So let's go and take a look at how we would apply this to the original x squared. So suppose we started with the original x squared. Let's draw a sketch of the original x squared. It would simply look like that. And let's go and apply each of these transformations. I'm going to go and apply the x transformations first. So I'm going to do the translation first by vector 4, 0. So what would that do? Well, it would take this coordinate 0, 0 to 4, 0 first. And then we multiply all the x values by a third. So if we multiply all the x values by a third, what would that then look like? Well, I'm going to just draw another set of x's here. That 4, 0 gets, that 4 is an x value. So this will get multiplied by a third and it would become 4/3. Okay. So that then becomes 4/3, 0. So it would look something like that. Just make it a bit symmetrical. It would look something like that. Right. So we've applied the x transformations there. Now I'm going to go ahead and apply the y transformations. So the y transformations is scale factor of 2 first of all. It's going to be timesing by 2. Now, in order to get there, well, let's just consider where we are first of all here. So this was y is equal to x minus 4 all squared. So this is after the translation. What did that do to our, well, let's find out what that point is there where it crosses the y-axis. When x is 0, y is equal to minus 4 all squared. So that value there is 16. What does it do to this one here? So the second one is both of the x translations applied. So let's write the equation of this. So this would be y is equal to 3x minus 4 all squared. So here we've then done what? We've multiplied all the x values by a third. This was 16 in the previous one. This is a y value of 16, so that does not get affected, so that stays where it is. Okay. So let's go and take a look at what happens to these coordinates. So we've got this coordinate here, which is 0, 16. We'll write it as a coordinate, because then we can see the x and the y quite clearly. So now we're going to apply the y transformations. Affects the y by a scale factor of 2 first. So all the y value gets multiplied by 2. So we went from there to there. Now I'm going to go down there. Next axis. So I'm applying the scale factor 2 to the y. So essentially it would become y is equal to 2 lots of 3x minus 4 all squared. So each of those y value gets multiplied by 2. So the 0, 16 now becomes 0, 32. This y value here is 0, so it remains at 0. The x value is unaffected. So this is now my sketch y is equal to 2, 3x minus 4. Apply the final y transformation. And the final y transformation takes it to 2 lots of 3x minus 4, which is what we had there, the previous one. And the y transformation is plus 1. So translation in the y by plus 1. So all the y values get added by 1. So what happens there, the 4 third 0, that would then become 4 third 1. The 0, 32 would become 0, 33. Okay, so it looks something like that. This becomes 0, 33. Okay, 4 thirds 1. And this is why, when we actually complete the square, we looked at before that we can actually determine the turning point. The turning point is simply determined by looking at the equation. It is the opposite. So what we have there is 4 over 3. There's my 4 over 3, and then the plus 1 at the end determines that. And that all comes from, essentially, the completing the square form is transformations applied to the original y equals x squared.